My name is Bhuvanesh Ashok and I am currently in my third year of pursuing a bachelor's degree in Computer Science and Engineering at JD College of Engineering and Management. My topic is FAISS, Facebook AI Similarity Search. My roll number is CS27, CSC 5th SEM, Section A. To begin, let's understand the core concept of similarity search. Imagine you walk into a library and say, I want books similar to this one I read last week. What the librarian does, trying to find books that match based on genre, writing style, or subject, is very similar to what FAISS does, but with numbers. In computing terms, similarity search means finding the items or vectors most similar to a query item, using measures like Euclidean distance or dot product. This concept is fundamental for systems like Google Images, Search by Image, Netflix, More Like This, Spotify, Suggested Songs. All of them are powered by vector similarity at their core. Similarity search is not limited to just images or videos. It spans domains like document retrieval, recommendation systems, audio analysis, malware signature detection. For example, when you're on Amazon and see customers also bought, and that's a similarity search comparing user behavior vectors. This makes FAISS a core utility for any application that needs to retrieve or recommend similar items from huge data collections. Let's now understand how FAISS makes this possible through indexing. An index in FAISS is like an organized catalog in a superstore. If every item had to be manually searched, it'd take hours. Instead, FAISS uses data structures called indices that store vector information in a way that makes it easy to fetch similar items quickly. Think of this like Google Maps. If you search for the nearest ATM, it doesn't scan every ATM in India. It uses spatial indexing to show results near you efficiently and accurately. FAISS offers a search method called IndexPlatL2. This is a brute force method, meaning it compares your query with every vector in the dataset. While this ensures perfect accuracy, it's slow for massive datasets, like trying to search for one name in a stack of a billion papers. Hence, for smaller datasets or high accuracy needs, IndexPlatL2 is ideal. To handle larger datasets, FAISS uses product quantization (PQ). Let's simplify this. Imagine you're trying to store 10,000 high-resolution photos on your phone. Instead of storing full quality, you compress them to thumbnails, saving space but still keeping enough detail to recognize them. That's what PQ does with vectors. It reduces memory usage while retaining similarity features, making large-scale searches feasible. Another advanced method is the inverted multi-index. This technique clusters data into multiple levels, like organizing a large clothing store into departments, shelves, and racks. When a search is made, only relevant clusters are scanned, drastically reducing time and irrelevant results. It makes searching faster by eliminating most of the noise early. FAISS isn't just an isolated project, it builds upon years of research in areas like inverted file systems, product quantization, multi-indexing, and it continues to evolve, especially with contributions from the research community in GPU acceleration, algorithm optimization. It's backed by serious academic work like the paper Billion Scale Similarity Search with GPUs, which reflects how far FAISS can scale. Shown that GPU acceleration can give an 8.5x speedup over CPUs. Moreover, it offers approximate search methods which trade off a bit of accuracy for much faster performance, sometimes 10x faster. For real-world systems that prioritize speed, like real-time recommendations, this trade-off is invaluable. Imagine needing to recommend a video within 100 milliseconds. You can't afford to be slow, and FAISS ensures you won't be. FAISS looks promising. Enhanced indexing will push speed and precision further. Multi-GPU scaling will allow even bigger datasets to be processed in parallel. Support for broader metrics will open doors for newer applications in bioinformatics, linguistics, and beyond. As data grows, the need for fast and accurate similarity search will only increase, and tools like FAISS will continue to be at the center. The real-life similarity search example. Imagine you're at a clothing store, you like a blue formal shirt and ask the store manager, do you have something like this but in black? What the manager does next, mentally filtering the collection for shirts with similar cut, fabric, and style, is exactly what similarity search does using math. It compares your input, query vector, with all available options and finds the closest match based on features. In summary, FAISS is much more than just a library. It's a foundation for how modern systems understand, retrieve, and recommend similar information at scale. Whether it's Netflix helping you discover shows or search engines finding visually similar images, Similarity search is everywhere. FAISS makes it scalable, accurate, and efficient, especially when dealing with billions of vectors. Thank you.